Computer Programming Essentials, Unit 6, Part 3. In our last unit, we talked about flowcharts and pseudocode and making decisions and single alternative if versus dual alternative if. In this section, we're going to talk about nesting if statements. We can put an if statement inside another if statement. We have to be careful about our placement of the else clauses because the else will always be associated with the nearest if. So think of first in, last out. It's a first in, last out basis. So whatever if is closest to the else, that's the one it's going to get associated with by default. You can change this with braces to indicate the beginning and ending of code blocks, but it's tricky, so we have to pay close attention to it. Here's an example. If the items sold is greater than or equal to the minimum items, we want to check to see if the total value is greater than or equal to the minimum value. If so, if both of those things are true, we are going to assign a sales bonus. And take a look at the code on the right hand side. If items sold is greater than or equal to min items, if total value is greater than or equal to min value, so both of those conditions are going to be true, and then the bonus will equal sales bonus. Notice that if neither of those conditions are true, or if either one of those is not true, there's no action that we take. So this is not an example of a dual alternative if. We can put both of those if statements together using the logical AND operator, and that's represented in Java with two ampersands. Take a look at the ampersand, and perhaps practice drawing that. You will be expected to draw that on your test. I just got back from grading the AP exams in Kansas City, and it's very common for students not to be able to draw decipherable ampersands, and it's tough for us as graders to grade them correctly if we don't know what symbol the tester is trying to draw. So it is helpful to practice drawing ampersands, and I encourage you to do so. What the AND operator says is both Boolean expressions need to be true in order for the entire expression to be true. So in this case, both items sold greater than min items must be true, and total value greater than or equal to min value must be true for this expression to be true. And take a look at the code, how they've written it there. If items sold greater than min items and total value greater than or equal to min value. Both of those expressions are true, then the entire expression is true, and it will set bonus equal to sales bonus. The OR operator says that either one or both are true for the entire expression to be true. Now take a moment to locate this OR operator. It's two pipes, and it's on the same key as the backslash key above the enter or return key on your keyboard. So take a moment. You might want to hit pause. Take a moment to locate that now. Welcome back. Using the logical AND or OR operators, this code represents that. Let's read the flowchart first. If items bought is greater than or equal to min items, you set discount rate equal to discount. Otherwise, you see if items is greater than or equal to min value. If that's true, then you set discount rate equal to discount. So either items bought greater than or equal to min items or items value greater than or equal to min value, either one of those are true, and it sets discount rate equal to discount. So take a look at how that's represented in code. It's a little more clear to use the OR operator than it is to set up that sequence of if statements. If items bought greater than or equal to min items or items value greater than or equal to min value, discount rate equals discount. So the OR operator makes that more clear. Either one or both of those can be true for the entire expression to be true. Short circuit evaluation dictates how these operators are evaluated. Now think about the AND operator. The logical AND says that both conditions must be true for the expression to be true. So when it evaluates the expression on the left, if it finds the first Boolean expression is false, it doesn't even need to go over to the right-hand side of the ampersand operator and figure out if that expression is true or false. Because if the first expression is false, there's no way that thing can be true. So it will short circuit and evaluate it to false. Similarly, with the OR operator, the OR operator says either one or both can be true for the entire expression to be true. So if it evaluates the first expression, the one on the left of the OR operator, and finds that it's true, it does not need to visit the right-hand side because it knows that the entire expression will be true. So it will short circuit to true. To make accurate and efficient decisions, sometimes you want to use if statements to check a range of values. And it's very helpful to be able to do that. And you commonly use an else and an if on the same line. So you can say if, let's think about an example. Think if you are checking tax rates. If someone makes over $50,000 a year, their tax rate is going to be one thing. Else, if they make over $40,000 a year, their tax rate is going to be something else. Else, if they make over $30,000 a year, and so on. Here's an example of when that might be true. If the sale amount is greater than or equal to the high limit, then their commission rate is one thing. If the sale amount is greater than or equal to the min limit, then their commission rate is something else. If the sale amount is greater than or equal to the low limit, then their commission rate is something else. But notice, in this example, they haven't used the else. So if I sell $2,000 worth of stuff, my commission rate is going to be 8%. But $2,000 worth of stuff is more than $500, isn't it? The medium limit. And so it's going to reset and set my commission rate to 6%. And $2,000 worth of stuff is also greater than the low limit, which is, oh wait, no, I'm good. It sets it less than the low limit. Anyway, I'm going to get the wrong commission rate because I haven't used else. So using else is really essential in this particular problem. It's most efficient to ask the question most likely to be true first. So it avoids asking, you want to minimize the number of times you ask a computer to figure something out, the number of times you ask a computer to make a decision. Because every time it makes a decision, it's got to stop and think about it. I'm exaggerating a little bit. Decisions happen very, very quickly inside a computer, but we do want to write the most efficient code possible, and we do want to minimize the number of decisions we ask the computer to make. So here's an example. If sale amount is less than low limit, then we set the commission rate equal to the low limit. If that's false, we check to see if it's less than the medium limit. And if that's true, we set the commission rate equal to the medium limit. If it's not true, we set the commission rate equal to the high limit. Notice that we were able to accomplish this in just 2 decisions. And we did have the else if. Sometimes we write that on the same line, and it's not done that way in this slide. But we've been able to isolate this particular solution to just 2 questions when there's really 3 different ranges. This is an efficient way to write this problem.